Welcome back to Math 130, Intro to Computer Programming with Java with yours truly, Professor Mimi Rasky. We're continuing Lecture 2. This is Lecture 2, Part 2, Hardware. So recall in last lecture video, we saw there were 4 big pieces of the hardware we were going to take a look at in turn, starting with the CPU, the Central Processing Unit. So a basic look at the CPU, you'll see that it has what's known as the ALU, short for Arithmetic Logic Unit, and then it has the control unit as well. So an instruction comes in, and the control unit is in charge of keeping track of which instruction is there, and the program counter especially, keeping track of what instruction we're on and what instruction needs to be done next. And the ALU will do some primitive operations, and then the result or output comes out of the CPU. Here's an even deeper look at the CPU. So the CPU's control unit fetches from main memory the next instruction in a sequence of program instructions. Then it decodes it, because it does come in the form of a number, ones and zeros, remember? And then it generates an electronic signal so that it can execute. And the signal gets routed to the appropriate component of the computer, the ALU or a disk drive or some other device, and the signal causes that component to perform an operation. So this cycle is known as the fetch, decode, execute cycle. Now let's talk about some basic primitives. A Turing machine is a hypothetical machine thought of by the mathematician Alan Turing in 1936. Recall from the last video that Turing is considered the father of computer science. Well, the Turing machine is a general example of a CPU, and the machine is supposed to be able to simulate any computer algorithm, no matter how complicated it is. And the Turing machine mathematically models a machine that mechanically operates on a tape. And in this slide, you see a picture of the actual implementation of a Turing machine. You see the tape on the left, and those are coming in with symbols, and then the tape on the right, which means the machine can write on the piece, an output piece of tape. And the Turing machines are not intended to model computers, but rather they're intended to model computation itself. Turing showed you can compute anything using 6 basic primitives, and a sequence of instructions are stored inside your computer, built from some predefined set of primitive instructions depending on your microprocessor. They may include arithmetic and logic, simple tests, and moving data. But thankfully, modern programming languages have a more convenient set of primitives. This allows us to abstract methods to create our own new primitives, which are going to be your computer programs you're going to write this semester. So the key idea, though, is anything computable in one language is computable in any other programming languages, although some languages are better at doing specific tasks than others. For example, MATLAB is really good at manipulating matrices, and Java is really good for mobile applications. Let's talk a little bit more about memory now. That's the next big piece up for hardware. The memory that we usually work with is RAM, random access memory. And RAM contains the currently running programs and the data used by those programs. RAM is divided into units called bytes, and a byte consists of 8 bits that may be either on or off. So if a bit is on, that's considered the number 1, and if it's off, that's considered the number 0. And the bits form a pattern that represents a character or a number. And remember, this is machine language from another video. Each byte in memory is assigned a unique number known as an address. RAM is volatile, which means that when the computer is turned off, the contents of RAM are erased. So here's a kind of little visualization picture of RAM. So you've got a column or row of cells here, and a section of memory is called a byte, where the byte's made up of 8 bits. And over here on the left are the addresses. Each location, you'll notice, has its own unique address. A section of 2 or 4 bytes taken together is often called a word. Here's a little bit of humor for you. Okay, now let's take a look at secondary storage devices, another piece of hardware. Secondary storage devices are capable of storing information for longer periods of time, so they're considered non-volatile. Some common secondary storage devices are disk drives, external drives, CD drive, DVD drive, USB drive, solid state drive. And I love this cartoon. Hey kid, have you ever seen one of these before? Which is one of those old floppy disks. Wow, cool, you made a 3D model of the save icon. Okay, another big piece of hardware are input devices. And input is any data that the computer can collect from the outside world, and that data is going to come in through input devices, such as the keyboard, mouse, what we're going to call a scanner, you'll see. Not the kind of scanner that you think of, but it could be the old-fashioned scanners. And digital cameras, very common. Now let's talk about output devices. Output is any data the computer sends to the outside world. And that data is displayed on devices known as output devices, and some common output devices are monitors and printers. And some devices such as disk drives perform both input and output, and those kinds of devices are called I/O devices, I/O standing for input, output. Okay, and to full circle come around, and why we even talked about the hardware is because we're going to be doing software in this class. But I reiterate, to be a good software programmer, you do have to have some knowledge of the hardware, because software runs on hardware, and it refers to the programs that run on your computer. So there's two classifications of software. You've got operating system software and application software. Operating systems operating system is a set of programs that manage your computer's hardware devices and control their processes. And most all modern operating systems are multitasking. So some common operating systems are Unix, Linux, Mac OS operating system, and Windows. I'm sure you've heard of at least one or maybe two of these. And the multitasking situation is called time sharing. And a multitasking system divides the allocation of your hardware and the attention of your CPU among all the executing programs. So you've probably noticed if you have too many tasks or windows open at the same time, it might slow down the system because of this multitasking and sharing of the CPU. And finally, we get to application software, which refers to the programs that make the computer useful to the user. And that's what you're going to be writing. And application software provides a more specialized type of environment for the user to work in. Common applications are spreadsheets, word processors, accounting software, tax software, games, and mobile phone apps.